All right, so let's talk about how do we find the vertex usually when we have the full equation ax squared plus bx plus c? Because we know that the b is doing some kind of left or right movement, but it's not exactly directly left and right. But how do we somehow use that information to help us actually find it? Well, previously we looked at you could build a table and graph it out, and hopefully you'll find the vertex. Or you could factor it. And we know that the where it crosses the x-axis, which is what you do when you factor it, that the vertex is exactly between where it crosses the x-axis. And so then once you find that point that's in between, you'll first actually find the axis of symmetry. You take that number and you plug it back in for x and see what you get out for y, which we did down here. But there's got to be a more formal way, because what if you can't find it with the table? What if you can't factor the problem? There's got to be another method. And of course, there is. But I want to show you some details as to where it comes from. Notice this. We said that the B term controls the left or right movement. And notice that it said -8. Okay? Notice that the vertex lied along the line x equals 4, which is what? Half of 8? And notice that the symbol is opposite. So that kind of has something to do with it. Does it hold true for the other problem we did? Well, notice this. It was -2, and it lied somewhere along the line of the x equals -1 position. Okay, so, well, the last one was -8, but it was +4 for where it lied. This time it's -2, and it's a -1. There must be something else going on. And in fact, it has to do with what the A value is. But let's just look at the actual details of where it comes from. That was a brief description. Oh, and by the way, I just want to say this. Position 1 here for the axis of symmetry is half of the B value. So there's got to be some connection between what the B value is and where the vertex will be. And here it is. Somebody figured this out. They figured out that you could always find the axis of symmetry, also known as the x-coordinate of the vertex, by taking your B value and dividing it by 2, but times the A value. So the A value still has a connection to it. And it says that right here. It says the x-coordinate of the vertex is -b over 2a, or twice a. So the symbol, the opposite of whatever the b symbol is, divided by twice a. And then it also tells us that that is true for the axis of symmetry. Well, because we know that the axis of symmetry runs through the vertex. So yes, the x-coordinate and the axis of symmetry will be the same. So let's do this. We need to be able to identify the B value. We need to be able to identify the A value, and then we can find the x-coordinate of the vertex. So let's do this. Let's start by listing the A, the B, and I guess we might as well list the C, although we don't need it for the vertex. So what is the A value on this? Well, it's the number in front of the x squared term. And in this case, since it's not written, that number is a 1. What about the B value? The B value is a 4, a positive 4. So we would say, all right, the B value is a 4. And I guess now what is the C value? Well, it's a -7. But it told us, just to the left there, that the x-coordinate was equal to the negative of b divided by 2 times the a. So let's just use that and plug in what we know. The negative is there, our b value is a 4, and we're going to take 2 times the a value. Now the a value is a 1. So what does this give us? Well, negative times 4 is just simply negative 4. 2 times 1 is, well, 2. And we could reduce this, and we should if we can. Negative 4 divided by 2, that is a negative 2. So that means on our vertex, and typically a vertex is a v with a parenthesis describing your x and y coordinate. So right now we know that it is negative 2 for the x position. How do we find the y? Well, it's like we did in the previous video, where we took our x coordinate and we plug it into the x position. In this case, there's 2 spots we have to plug it in, and then we solve it out. So here we go. We want to find y, so we're going to plug in negative 2. And let's do the math. Y equals, well, negative 2 squared is a positive 4. Then 4 times negative 2 is a negative 8. And then we have the minus 7. So now we just need to simplify. Y will equal, well, here we go. 4 minus 8 is negative 4. Minus 7 more is negative 11. So the y coordinate is negative 11. And very quickly, with relatively limited math in comparison to what we did in the previous video, we can find the vertex. All we needed to know was what the b value was and what the a value was. Let's try it again. Again, let's list the a, the b, and the c, although we don't need the c for the x coordinate of the vertex. The a this time is a 2, so we're going to put a 2. The b is a positive 8, so there's an 8 there, and the c is negative 14. But we know that in order to find the x coordinate, we need to take the opposite of b, also known as negative b, divided by 2 times a. So let's plug in what we know. The b value is an 8. The a value is a 2. Negative times 8 is negative 8. And 2 times 2 is 4. Negative 8 divided by 4 is a negative 2. Okay, so we happen to end up with a vertex that also goes on negative 2. But what is the y coordinate? Well, to find the y coordinate, take what we have and plug it in. And we have 2 spots to put it. So here we go. Y is equal to 2 times negative 2 squared plus 8 times negative 2, then minus 14. Negative 2 squared is negative 2 times negative 2, which is a positive 4, times 2. That gives us 8. Then we have 8 times negative 2, which is a negative 16. And then we have minus 14. So here we go. 8 minus 16 is a negative 8. Minus 14 more, we will get y equals, and I'm going to write this step so you can see what we did, just because I didn't write it on the last one. It'll be y equals negative 22. So our x or our y coordinate is negative 22. And there we go. We have found the vertex with relatively quick mathematics. Definitely a lot more effective than trying to graph it, pick some points, which is still acceptable. I think this is still a great method, and you should know how to do this regardless if you're looking for the vertex or not. Just being able to graph a function is a very good, useful tool. But we should also realize that there are other methods like factoring. If you can factor it, it's very quick to find the vertex as well. However, problems that we don't know how to factor are a little more difficult. So knowing how to do this using this third method is super good. Let's do it one last time and we will call it good. So here we go. We got x equals the negative of b over 2a. In this case, the b is an 18, so the a is a 3. Negative times 18 is negative 18. 2 times 3 is 6. And negative 18 divided by 6 is negative 3. Now, in order to find the y-coordinate, we need to plug that negative 3 back into the function. So y will equal 3 times negative 3 squared plus 18 times negative 3 plus 5. Now, I do want to show you this because I think it's valuable. You can type the entirety of this into a calculator. Not that we should be doing that all the time because we should be able to handle some of this math. But let's say you don't know what some of these are, such as 18 times negative 3. It's acceptable to take in what we have, but you should have parentheses around absolutely everything that you have plugged in. And knowing how to type it into a calculator is a valuable too. But what is that? Plus 5. There we go. We should not always rely on a calculator. We should be able to do some of this by hand, which is why I didn't show it until now. Look at that. Y value of a negative 22. So we have found the vertex. The very bottom or top. In fact, I want to mention it on this one. Since the a value is a positive 3, this vertex will be a minimum. Go back to this one. The a value is a positive. So again, this vertex will be a minimum. And I guess here the a value is also positive, so it will also be a minimum. All right, there you go. How to find the vertex of any quadratic function.